Hello ladies and gentlemen, and welcome to your lesson for your buyout day number 3. What I'm doing is we're going to look over some of this material. I'm just going to warn you right now that you may hear some interesting noises in the background. I have puppy problems today, and so if you will notice, I have there she is. We have a puppy that is busy at the moment, working away on a problem that I gave her. We gave her, took 2 of her toys and I put one inside the other. And it seems to be keeping her busy quite well while I do this video. But you may hear a few growls and a little bit of frustration from Puppy, which is, that's okay. All right, so what we did the day before was we took a look at a number of functions. And I wanted to think of them in terms of their lowest, basest, most easiest form of any of the functions that could take. And we came up with, we thought that we'd look at the quadratic, an exponential of base 2, the root function, the reciprocal function. We then thought that we would talk about an absolute value function, the cubic function, the exponential with a base of 3, and an exponential with a base of 1/3. And so we did a quick little table of values, and we were able to come up with the graph of all of them, and we talked about the domain and range. So this is the base quadratic, and you need to know the base quadratic has this equation, and has this graph. So it's 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. We need to know that inside out. We can't be doing this to get it. We have to know it. Exponential of base 2. Well, we know that that's going to be exponential. Base 2 is going to be exponential growth. Okay, you can see it here. It's actually doubling time. So if we put in 0 for x, we get 0, 1, 1, 2. Those are the 2 most important points. We also come up with negative 1, 1/2, and maybe 2, 4 will allow us to get a nice little shape of that curve. So you need to know that. You need to know those points and know that it's going to look like that. The root function. We need to know that the root function starts at 0, 0, goes to 1, 1, has another point of 4, 2, and 9, 3, and so on. Now it also has all these other points, but they're not perfect squares, which means they work out to decimal, so it's just easier for me to work with these points. Remember, a table of value just shows some of the points that you're going to choose. A graph shows all the points on the domain. So this is only a subset of the domain for the root x. Root x has a domain actually greater than or equal to 0, but I certainly couldn't have a table that kept going on and on and on for all values that are greater than or equal to 0. My reciprocal function, 1 over x. 1 over x has 2 main points that we need to know, 1, 1, negative 1, negative 1. And you'll notice that there's 2 asymptotes with this function. The asymptotes are not part of the graph, but we draw them so that you know where they are. So this graph is going to get closer and closer and closer to 0 from the right. The graph is going to get larger and larger and larger. As we go this way, as x gets larger and larger and larger and larger, or moves to the right, then the curve comes closer and closer to 0. So we have a vertical asymptote and we have a horizontal asymptote. Then we took a look at some other functions. We took a look at the absolute value function. Now the absolute value function I want to spend a little bit more time talking about today. What an absolute value bar does, and that's what these are called. These are called absolute value bars, okay? They're not brackets, but they go around a function like brackets would. Now what they do is if I have plus 3, the absolute value takes away that sign and just makes it 3. And the absolute value of negative 3, or the absolute values take away the sign and just make it 3. So the idea is it gives me just the absolute value regardless of sign. Now the way to think about this is that if I had a number line, and if I had plus 3 out here and negative 3 down here, the idea of plus and minus is actually a direction. This is all the positive numbers if I go to the right of 0. These are all the negative numbers if I go to the left of 0. But if I want to know how far it is from 0 to negative 3, it's actually just 3 units. No negative. The distance from here to here is simply 3 units. And the distance from here to here is also 3 units. So the absolute value from 0 to positive 3 is 3 units. And the absolute value, or the distance from 0 and negative 3, is also 3 units. So there you go. That's how the absolute value works. So when I put in negative 2 for x, the absolute value of negative 2 is 2. Negative 1 is 1. 0, 0, 1, 1, 2, 2. Which means if I go over 1, I go up 1. If I go over 2, I go up 2. If I go over 3, I go up to 3. And this is going to give me the nice linear side here. I get another linear arm here. They meet at 0, 0 at a point. And that's what it looks like. It's not a parabola. These are linear sides. They're not curved. Cubic function. Well, the cubic function looks like this. Goes from 0, 0, 1, 1 to 8. So it really starts to take off once these domain values start kicking in. And the same happens this way. Exponential of base 3. Well, the exponential of base 3 looks an awful lot like the exponential of base 2, which looks an awful lot like the exponential of base 5. The only difference is how steeply it rises. So they all go through 0, 1, but since it's base 3, at x equals 1, the y will be 3 because it's base 3. Had it been base 5, over 1 I would have gone up to 5 and it would have rose steeper. But it still has the same doubling time shape. It's not doubling time. This would actually be tripling time. It is an exponential of base 3. Frankie, sorry about that. Frankie's trying to chew through the wires. Now, exponential of base 1/3. Now, what happens here is this is in fact going to be a decreasing curve. So if I put in negative 2, I got 9. Negative 1, I get 3. 0, I get 1. And you'll see that the curve actually falls this way. This is what we call a decreasing curve from left to right. It still goes through the point 0, 1. But its most important point now will be 1, 1/3 and negative 1, 3, which gives us that shape. Those are your base curves, and then we wanted to use them to be able to answer some questions. I'll come right back after I make sure that Frankie doesn't chew through a power cord.